Let's take a look at an ASC712 current sensor. Here's a diagram of the chip there. Now, they come on a little module like this, and this was from China. It was like 80 cents. So it's probably a fake chip, but we'll see how it works. Now, they work on the Hall effects principle. So they have a little Hall effect sensor in there, and they monitor the current. So what happens on this analog pin out here, typically it'll put out 2.5 volts. There's 5 volts in, half of that 2.5 volts onto your analog pin when there's no current flowing. And then every time for 1 amp of current flows, the voltage will increase by 100 millivolts, okay, on a 20 amp unit. This is a 20 amp unit, so it's going to increase by 100 millivolts each time. So that's how you can calculate the current. And so it has a your base voltage on there. It's supposed to be 2.5 volts. In this case it wasn't, but we can adjust that in the code. And then for every 100 millivolts increase, that's going to be 1 amp. Okay, so here's the unit over here. Here's the unit right here, and this is on a board. This is a DIN rail mount here. This is a little project I'm working on. I'm gonna add a current sensor to it, or no, current sensor plus a temperature sensor, and then probably a PID loop, or maybe just a PI loop, and control a reflow oven. And if that fails, then I'm just going to turn it into a coffee warmer. So that's my project. Anyway, it's all on DIN rail, so I can move things around and replace it whatever I want. But for right now, I'm just going to test the current sensor, see if that works, and see if my LCD screen works. Okay, so you can see on the screen that there's no current flowing, and it's putting out 3 volts, 3.06 volts. Okay, so here's the Arduino sketch, and so we have, can you see that? Yeah, so we have we include wire, and then the liquid crystal, the I2C version, and then the liquid crystal, usually the address on those is 0 times 27, and this just happens to be 20 by 4. Okay, now IC, or I2C standard, it stands for integrated circuit. Okay, so the I2 is integrated, and then you have the circuit. So, and then you have a this float multiplier. That's a 100 millivolts, and here it is over here. So for a 20 amp unit, it's going to be 100 millivolts. So for every 100 millivolts increase, that's going to be 1 amp. Okay, and then all we're going to do here is we're going to read the voltage off of the analog pin here. 5 divided by our 1023, and then we take that read and we minus the 3 volts, 3.07 here. I think I've changed that to 3.06, and then we divide by our multiplier, which is our 100 millivolts. Okay, and that should give us our current. Okay, and then we're just going to print that out to the LCD screen there. Okay, so I'm printing out the voltage and the current, so we can tell what voltage we have on there. Okay, so that's all there is to the unit. Now, in here I have a switch here that's going to control the relay here, and then when the relay kicks in, it's going to put current across the current sensor there. And to put current on there, I just have I got a 12-volt battery, and then a rheostat, a big one. So, and so we'll turn it on and we'll see what happens. So, okay, so you can see that at 1.4, well, it's bouncing all over the place. It's a 1.4 amps, and can you see that one? Yeah, there we go. That's better. Yeah, let's do it like that. Okay, yeah, 1.39, and this is fluctuating around. So in the code, what I'm going to do is I'm going to take an average of that current there. It's bouncing all over the place, but I'll take an average of that, and that'll smooth that out. So it should be close to the 1.39, and then I can adjust that up. So 1.69, 1.8, 2. So it's bouncing around at 2 there. So a little higher there. So that's it seems to it's going to work out all right. And then I start out slow, so I start out with the, you know, make sure this sketch works, and then I can add to it as I go along. So anyway, that's going to work. Thank you.